Okay, let's go see YouTube that we're live. Are we live? Are we live? Let's refresh. Yes. All right, so today we are going to do research together. Let's look into Lorentz transformation. Why am I looking into Lorentz transformation? So in the previous video, we were discussing the Michelson-Morley experiment. And my intuition is not just my intuition. I've heard from a reliable source, as they say. I'll just give credit to the source. Do I have him somewhere? Yeah, there he is. Let me show you this guy. Yeah. So this guy.
The key to the next revolution.
This guy, his channel is Inductica. Definitely recommended. He doesn't have many videos, but this video is really good. I've watched it, I think, more than once, at least some of it. So in this video, he discusses the Michelson-Morley experiment, and he says that it should be compensated. It's self-compensating, meaning it should give you the null result. Is this it? This is his discussion of general relativity. He's getting it wrong, but his ether. I like his ether explanation. Let me just find his diagram of Michelson-Morley. He gave me a lot of ideas. A lot of what I'm saying is after I heard him. I think it's difficult to know where there is the Michelson-Morley. I wish I could stop the video at this point. Let me just, you know what, let me open this separately.
Physics has been hiding in plain sight for over a century.
So where is...
So if Lorentz discovered length contraction, then why is Einstein the one who's remembered?
So let's see what he says about Lorentz.
Normal narrative that Michelson-Morley disproves the ether. Lorentz
Let me look back
would shorten
a little bit.
Smashed orbit, like
more.
Maxwell's equation. Mind that's the ultimate argument.
More. Let me see.
However, this simply isn't the case. First, and most importantly, this experiment doesn't explain how waves can exist where nothing is waving. So I want you to keep that firmly.
Let's try more.
Slow down as it moves upwind.
So, wait.
The Michelson-Morley experiment was an ingenious experiment.
Let's try this.
Now, what is a field? A field is a property with different quantities at different locations.
Okay, this is the... I agree with everything he says.
Now, think of it this way. A property must be a property.
So a lot of what... This notion that we need to bring back the ether, I got from him, I think.
Everywhere. That's the argument for the ether.
So he needs to get a lot of credit.
Of fields requires a medium. Just as sound is a changing property of air, the pressure, these different fields is to these different fields. Now, many of you are probably saying, hold up, James. Before you get carried away, didn't the Michelson-Morley experiment disprove the ether? No. Let me show you. For those of you unfamiliar, the Michelson-Morley experiment was an ingenious experiment conducted in 1887 to measure the speed the Earth traveled through the ether. In this experiment, light was shot out of this emitter and passed through a beam splitter. A beam splitter is an optical device which allows half of the light to pass through it, while the other half is reflected. This will create two separate beams. Each of these two beams is reflected off of a mirror so that it's then brought back to the beam splitter. Now, once this happens, part of beam B is reflected off the beam splitter, while part of beam A is transmitted.
Oh, this is maybe a little bit confusing. So beam B, so let's, okay, this is the emitter on the left. So it goes to the right, gets split. So beam A goes up and then down and all the way down. And beam B goes to the right, then left, and then down. Okay, so the split is here. This is A going there, A coming back, and A going all the way through. And then here starts B coming back, and B going all the way through. Okay. But what's the direction of the ether? Let's see.
Which brings A and B together at the detector at the bottom of the diagram. Now, because these beams are waves, they will cancel and strengthen one another in a pattern which looks like this when they overlap at the detector. Now, the Earth moves really fast around the sun. So the Earth should be moving through the ether, which would cause an ether wind to blow through this setup. Now, to keep things simple, let's say that the ether wind is blowing along the...
Which is something that I believe in. So, but I believe that we would notice the ether blowing into Earth. And I think I have the setup to prove it. That the ether currently is blowing at 6 million meters per second towards the center of the Earth, towards the Earth's surface from above, and it's blowing right through us. It's very difficult to detect it because we are in its path. I mean, any clock that we use, any device that we use will always be affected by this ether. So how do you prove something that is influencing every device, every subatomic particle is influenced, there's no particles, but every subatomic wave or particle wave is influenced by this ether because they all these particle waves are moving are interacting with this ether. This is the medium in which they exist. I mean, their very existence is as waves in this medium. They don't have any other existence. They're not particles in of themselves. They're not separate from the ether. They are the ether. Every particle we are aware of is just, we are beings, we are creatures, we are made out of ether. It's difficult to believe. We are the ether. Everything about us is the ether. So of course we're gonna have an issue discovering this ether. It's not even fish in water. It's water fish in water. It's very difficult. It's even more challenging. So okay, but this experiment, at least they tried and failed, but they should have continued. They should not have stopped. Unfortunately, Einstein came in and he said, "Forget it. There's no ether." That's not possible. That's an unscientific claim. Of course, there is an ether. Otherwise, you cannot have electromagnetic waves. The ether is the medium of electromagnetic waves of light, and everything waves. Everything, right, in quantum field theory, everything is waving through something. That thing is the ether. This is what this video is all about. And to say that this experiment rejected the ether, that's so he claims that's not true, and it's possible to explain it away with the Lorentz transformation, which is what I want to look into. But first, let's do a review to see what he's saying, so everybody's up to speed.
Direction of beam B. If this were the
So the blue from right to left is the ether. So let's imagine that's the ether. So okay, so that's the ether. So in that case, let's see what he says.
case, then beam B would be traveling upwind at first, then
Wait, did he say beam? Yeah, beam B is traveling upstream. I wouldn't say upwind, unless he's talking about wind, or maybe he's talking about the ether wind. I would say stream. So it's upstream or upwind. Beam B is traveling against the waves, against the stream, which makes it very slow, and then back again, which is very fast. But they don't compensate for each other because, which is, for me, is counterintuitive. Like it's not going to be the same. You can see that it's not the same because if the stream is at the speed of the wave, then beam B can never get to mirror 2. Even though on the way back it's very fast, but on the way there it's very slow. So, right, initially, let's say it takes 1 second there and 1 second back. But as the stream becomes stronger and stronger, it takes more than 1 second and 2 seconds and 3 seconds and 4 and 5. It can take hours and days and years for the beam to reach mirror 2 and then come back. So these two speeds don't compensate for each other. It's not like it's always going to be the same rate. So this definitely slows down. Right? Your intuition might be, yeah, it's going there and back, so it should compensate. On the way there, it's slow. On the way back, it's fast. But it never, even if the way back takes 0 time, the way from the beam splitter to mirror 2, it could take an infinite time. We could create a black hole easily with water or any other medium. So it doesn't compensate, but it takes a certain amount of time, and this one up and down also takes longer, but it doesn't take longer in the same way. It takes longer in a different way, such that they should become, they should interfere with each other. Let's hear what he says.
And downwind after it reflects off that mirror on the right. Since light is a wave of the ether, beam B would be slowed down as it moves upwind and sped up as it moves downwind. Now, doing the math, this all has the overall effect of slowing down beam B. So overall, going back and forth, it takes longer as a result of this wind. Now, after recording the
Oh, it slows down both A and B, but it should slow down B more. I don't think he understood that. I don't know.
pattern in the detector, Michelson and Morley then rotated the table that the experiment was mounted on. This would cause a change in the speed of both A and B, since each would now be.
So now A and B are different. They're shooting the beam from the top, and now A has to travel up and then back down to the detector. And B, so A now has to move slower. I mean, you should have. The question is, which way is the wind blowing? So they're trying to detect one way or the other. They should detect an interference. Maybe both ways they should get an interference. But in this case, let's say A should be slower. They would see the same interference unless these were different colors. No, I don't know. I don't even think you. I mean, why would they need to rotate? I don't understand why they would need to rotate. Either way, you should get an interference. The first order of business is get an interference. I don't see why you need to rotate a table. What do you get from rotating? Right, this way you should, any way you orient the table, you should get an interference pattern. So if the table is this way, now A should be slower than B. B should be slowed down, but not as much as A. Let's assume that the math is correct.
Be going in a different direction with respect to the ether wind. This will make A and B each be in a different part of their wave cycle by the time they reach the detector, which will cause a measurable difference in the pattern they make when they combine at that detector.
It should be, I think you should always get, I don't know, maybe you should always get the same interference pattern. Maybe the interference pattern should change, but you should always get, in my opinion, an interference pattern, except for maybe in certain cases. But in the two cases we just saw, we should get into the same or the opposite interference pattern, which means that halfway through at 45 degrees, we should not get an interference pattern. So maybe that's the reason they should rotate the table. But if they rotate by 90 degrees, they will never get an interference. They need to rotate by a little bit every time and get, and get results. But the fact of the matter is they never got any interference patterns.
In this way, Michelson Morley planned on measuring the speed of the ether wind. This experiment required painstaking precision. Michelson actually suffered a nervous breakdown while trying to conduct the experiment. And after all of this effort, they detected nothing. Michelson and Morley tried a number of tricks, but they couldn't get this apparatus to detect motion through the ether. Modern physicists have taken this as proof that there is no ether. However, this simply isn't the case. First, and most importantly, this experiment doesn't explain how waves can exist where nothing is waving. So I want you to keep that.
Yeah. I mean, if you say, as Einstein, that there is no ether, I think Einstein, we need to look into this. What did Einstein exactly say in his seminal 1905 special relativity paper? Now I really need to read it. I mean, I thought I can skip that piece of history and not read it, because I need to blame someone for this mess that we're now in with physics and science and philosophy. It's completely screwed up at this point. It's just too messy. I cannot live with the way the world is, and the world. I mean, I think we're facing World War III at this point, and it's ultimately because of this. I think science has gone completely sideways. And I think the reason it all started around here with just about Einstein. I mean, I think Einstein dropped the ball, and everyone followed him. Everyone, including me, we all worshipped him, I think, and science got destroyed because of this. Because Einstein's theory is unscientific, exactly for the reason Inductica, I think his name is James, exactly what he said just now. So you cannot simply say there is no ether. That's not possible. That's unscientific. Right. However, this simply isn't
the case. First, and most importantly, this experiment doesn't explain how waves can exist.
Exactly. First and foremost, it's not and mo. I don't know. Most importantly, this experiment doesn't explain how waves can exist. Exactly. So you cannot have waves. Waves, by definition, the definition of a wave is the motion. It's not even the motion. It's the it right. It's the illusion of motion. Something seems to be moving, but it's not. Nothing is really moving. It's not motion. It's the propagation of energy. This is the way my high school teacher. Once I asked him about the speed of light, and he said, "Well, what is a wave? A wave is the propagation of energy." I think this is the most beautiful definition. If my high school was worth anything, it was worth it just for this to hear it from my physics teacher. That he said, light is just, or waves are the propagation of energy through a medium. So beautiful, just perfection. Yeah, he was a good physics teacher. Too bad I can't tell you his name. He was a good teacher. Really weird name. I think he was. I'm not gonna say. Anyway, so so right. So you cannot. So Einstein coming in and saying, "Well, it's a vacuum." That's we'll look into Einstein. We'll have to do our research. But but the way modern physicists say that there is no ether and waves are waving through a vacuum, that's nonsense. I completely agree with Inductica. And I never heard this from anyone. He's the first person to actually say this. So hats off to him. So you simply cannot dismiss the ether. That's impossible. You cannot dismiss the ether. That's unscientific.
where nothing is waving. So I want you to keep that firmly in mind, that that's the ultimate argument
I'm sorry.
for the ether, is that something has to be waving. But second, it's worth noting that the physicist Heinrich Lorentz was actually able to explain this negative result using the ether. Using Maxwell's equations of electricity and magnetism, Lorentz calculated that the electromagnetic field produced by the atomic nucleus would change depending on the nucleus's state of motion. This change in the field of the nucleus would change the circular orbit of the electron.
So this is the Lorentz transformation, and this is Einstein's theory of relativity. This is length contraction. So if this is true, and the whole apparatus is getting shrunk because the entire planet and us and every subatomic particle, well, the subatomic particles themselves, no, but since they are waves, of course, if they are waves, and then it's possible for them, for their motion, for the space in which they're moving is being contracted. Everything is contracted as it moves through the ether, except for the ether. So the ether in this case is not contracting. Maybe we can notice it. We can notice the Earth contracting as it's moving around the sun. I don't know if we can notice it because I know that there is a motion. I mean, I can predict the motion of the ether because the ether, it's not a wind, it's just gravity. So on Earth, we would notice the ether always flowing into Earth, and it's symmetric, completely symmetric. It's completely symmetric. Is called isotropic, I think. It's completely symmetric around the nucleus of the Earth, the center of the Earth. So it's going to be difficult to. But we could aim. Oh, we can find out. Yeah, but the problem is, well, it's always the apparatus is becoming contracted. If this is true and this is compensating for the length, then how are we going to find out? Anyway, the flow of the ether is gravitational flow, which around Earth, it's towards Earth. Simultaneously, it's a little bit towards the sun. That's what's dragging us towards the sun. A little bit, we're experiencing drag towards the moon. The moon is causing a little bit of slowdown because we need to pull the moon towards us, and the moon is pulling us a little bit towards it. We have tidal forces. We're experiencing tidal forces, so we should be able to explain that through the flow of space. And the sun is attracted to the center of the galaxy as it's rotating about the center of the galaxy. So we must have a little bit of ether flowing towards the center of the galaxy. And our galaxy is part of a cluster, so we should be experiencing a little bit of ether because of that, and our cluster is orbiting some other group of clusters or who knows what. Anyway, at one point, so you can do a calculation, you can figure out the total flow of ether in the universe, which is incredible because it's so funny that the ether, they were looking for the ether and they were thinking left and right. They weren't thinking up and down. They did everything they should have looked, but they were ignoring the fact that the ether might be blowing right through the apparatus towards Earth. It wouldn't have helped. It's so funny. The ether is stationary, basically stationary, uh, uh, horizontal. I mean, it's there is no motion. Basically, there's no motion of ether horizontally. The entire motion, they weren't thinking about it. It's completely through their apparatus right towards the center of the earth. But it doesn't matter. They would never have noticed it. That's the one thing they didn't try. They didn't say, "Oh, maybe it's blowing right into the center of the earth." They wouldn't. They didn't think about that option. It's so funny. And they did everything they can with liquid what do you call it, silver, not silver, liquid not what is like the stuff you use. I think he discusses the apparatus. So it was floating on the liquid, which made it completely horizontal. If it would have been just a little bit not horizontal, it would have been better. But there's no way they could have. According to his explanation, there's no way they could have detected it. In any way, it's invalid just because of that, because they weren't looking into the option that's blowing into the center of the earth. They would not have detected it if it would have been detectable, which is funny in of itself. But so it's invalid. So my previous video that I said seems invalid, it's invalid because of that. But let's ignore it because according to Inductica, it would have it's invalid because of the Lorentz transformation, which is what we're researching right now. So funny. This is such a rabbit hole. It's like it's so confusing. But this shows you should never ever trust anyone about anything. You always, as difficult as it is, you should always look at everyone, what they're doing, and always double, triple, quadruple everyone's work. Never trust anyone. Always give it, okay, try and make it as independent as possible. Let me get a sip of water. This rabbit hole, Jesus, this is one rabbit hole. I can't believe it. I'm so upset that I always trust people. Always, always. It's not about trust. You always need to overlook everyone. You cannot trust Einstein. If you cannot trust Einstein, who can you trust? It's like even everyone dropped the ball. Everyone dropped the ball. So you can never trust anyone. You always have to. This universe it's in your hands. Jesus. You cannot trust anyone. It's not like you cannot trust you cannot trust anyone, 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 anyone. Everyone is worshiping the same God. You cannot trust them. Everyone goes to the same cocktail parties. No one is independent. They're all cults. All this, the entire science apparatus is one big cult. I'm sorry. I'm sorry. You cannot trust me. You cannot trust me. Don't trust me. Always read, like, do everything I show you, look into it. Never trust me. Never ever trust anyone. Never, never, never. Otherwise, you will destroy the universe and it's your fault. And we know this universe. We know that humanity is not going to make it. Right now, we seem to be heading towards World War III. Unfortunately, I don't know how this is going to end. I mean, this could end very quickly, very badly. Either way, we're hopeless. I'm sorry. sorry to be the bearer of bad news. It's hopeless, but you cannot. I don't recommend giving up. We have to try, and because trying to save the universe is enjoyable. So that's the biggest joy I have to offer you. We have to do our best, and we know we're gonna fail. This is like Star Trek, the no-win scenario. What do you call it? What do you call the Star Trek no-win scenario test that they had at the Academy? You're gonna fail. You have to go through two ships and destroy your ship, and everyone is gonna die. It's not about succeeding. It's about how well can you fail. So we know we're going down with the ship. We cannot. I mean, maybe we can rescue someone, but we don't have the technology to rescue anyone. This planet is doomed. I mean, you have to build a ship and get out of here, but you cannot leave any trail because they're gonna send something to destroy you. They're not gonna let anyone escape. So they will destroy you. So but you have to try. But unfortunately, as you try, I have to recommend the only way you can escape is if you escape and destroy everyone behind you. But then you fulfill the prophecy of the destruction. So anyway, you're going to, the prophecy will be fulfilled. Humanity is doomed. I mean, it's a mathematical prophecy. It's just a game theory. That's all it is. It's the prisoner's dilemma coming back with a vengeance to haunt us. That you have to betray your friend. In the long run, you have to betray your friend. But no one. But if you betray your friend, then you have become the bad guy. I don't know. I don't know how to save you. I don't know what to tell you. You're in trouble. We're all in trouble. I hope I'm wrong, but everything points at me being right. Namely, Fermi's paradox. But let's continue. All right.
Electron into this elliptical smashed orbit like this. Now, since Michelson and Morley's table is of course made out of atoms, this would cause the table to get smashed by this exact same amount, shortening the distance that beam B must travel. Now, upon doing the calculations, Lorentz found that the change in length of the table along the direction of the ether motion would shorten the path of the beam just enough to cancel the amount.
So if Lorentz was able to explain this, they should have gone with Lorentz and not with Einstein. Why did they go with Einstein?
But the ether wind would slow that beam down, making it appear to be going the same speed as the unaffected beam. Now, today, of course, we know that length contraction is real. Contrary to the normal narrative that Michelson-Morley disproves the ether, Lorentz actually discovered length contraction before Einstein by using the ether to explain the Michelson-Morley experiment. So if Lorentz discovered length contraction, then why is Einstein the one who's remembered for it? Einstein ditched the ether and instead derived length contraction from the assumption that light is measured.
So every time they teach Einstein's relativity, they always teach Lorentz contraction and Lorentz. Everything has to do with Lorentz. But then they call it Einstein's theory of relativity. That's ridiculous. Einstein didn't explain. Then Einstein never explained anything. He just confused everything. And he got credit for explaining everything? Jesus. How deep is this rabbit hole going to go? So Lorentz explained it in a simple mechanical way, and Einstein confused everything, confused everyone, got credit for explaining it while making a complete mess out of everything, making everything unscientific? What is going on?
To be the same speed for all non-accelerating observers, regardless of their speed. The way this assumption is usually explained is that if you take two observers, one stationary, another on board a spaceship traveling at half the speed of light, and the moving observer shines a flashlight, then that moving observer will measure the light as running away from him at c, the speed of light. Now, common sense would then tell you that the stationary observer would observe the light moving at 1.5 times the speed of light.
All right, so he has a diagram and this is the stationary, the relatively stationary guy. This guy is accelerating, but he's not really saying he's accelerating. He's just moving at a constant speed. This says, okay, and he measures v light to be c. I don't like whenever they show this. This never made any sense to me, and this can never happen. No one has ever measured the speed of light one way. It's like one of those things that no one ever measured or can measure. We've never measured one way the speed of light. You can only measure it going there and coming back, and then you measure what you got. And it's always measured as a constant. So as you go faster and faster, assuming there is an ether, so it should, right, let's say you're going against the flow of ether, faster and faster and faster against the flow of ether. So at one point, so it should slow down, because at the speed, if you're moving at the speed of the wave, then the wave should never be able to move forward. So you should get an infinite time. So before then, it should slow down. So because of that thought experiment, you expect you going through the ether, forward or backwards, should slow down the time from there and back. But this doesn't. But you're not considering the fact that your clock is slowed down, because your clock is made out of light. Everything about you is flowing through the ether. You are all exactly like this wave. So you can never measure anything to do with this wave. To you, this wave is always going to be traveling there and back at the same speed, because your clock, this entire thing is invariant, is ether invariant. This thing can never detect ether, because it is ether invariant. It never gets influenced by ether. That's the problem. That's the problem with the ether. The fact is that the ether is the fabric of reality, because all our reality, we're all sitting inside ether. There's nothing. Everywhere you go, you cannot escape. As far as I can tell, you can never escape the ether. So since we are the ether, we are the ether. We're waving through the ether. We're waving through the ether, just like this light wave. We're waving through and this is not me. This is just quantum field theory. So quantum field theory agrees that with everything I'm saying. So according to quantum field theory, which is just modern physics, so according to modern physics, this apparatus can never detect. This has nothing to do with special relativity. You don't need special relativity. You just need basic logic. If your clock internally does the same as this moving back and forth, your clock internally does the same. Oh, and on top of that, there is contraction. So the whole thing is experiencing contraction, but it's according to Lorentz. We still need to look into Lorentz. Everything is compensated. Then you don't need the theory of relativity. You need the theory of Lorentz. So, and Lorentz is just Maxwell. Lorentz claims that it comes from out of Maxwell. So this is just Maxwell. So according to Maxwell, this is undetectable. So but Maxwell didn't know that everything is an electromagnetic wave. Everything behaves the same as if it were electromagnetic wave. Wait, does it? Well, that's what they say. They said that everything, all the subatomic particles move at the speed of light. This is, right? And mass is just an illusion. All subatomic particles move at the speed of light, except for when they interact with the Higgs mechanism, which again is a mechanism of the ether, of the fabric. Maybe I should just say ether. I mean, every time I say ether, fabric, and the unified field, it's just different words. Ultimately, it's just the ether. Anyway, let's continue.
Light. But Einstein's assumption states that the stationary.
Wait, so what are we seeing here? So he's met V of light is he's looking at this wave and he's measuring this light going there and back as C. But how is he measuring? All that he's seeing is what this device is saying. Now he cannot measure this. He's just this guy is just looking at this guy, and he's measuring this light going back and forth at the speed of light according to this guy. So that, which is exactly what you'd expect in any field. In water, it should be the same, or in sound, it should be the same, as long as he's stationary. If he's moving through the air, and this clock, if it's a sound clock, yeah, I don't know what would happen, because we need to look into Lorentz invariant. So I haven't done the math. You shouldn't trust me. Anyway, but what he's trying to say, that this guy is moving at half the speed of light relative to this guy. So the spaceship is moving at half the speed of light at a constant speed, even though the engines are on. So ignore the engines being on. So, and this guy sees the speed of light as a constant, and this guy sees the speed of light as a constant, but this guy is moving at half the speed of light relative to this guy. How could that be? So this guy sees this guy moving at half the speed of light, yet this must be moving at the speed of light. This guy's moving at half the speed of light, but according to him, this guy's saying, I'm stationary. Light is moving at the speed of light. What is he trying to say here? I'm getting lost in the dialogue tree.
Stationary observer would observe the light moving at 1.5 times the speed of light. But Einstein's assumption states, the way this assumption is usually explained is that if you take two observers, one stationary, another on board a spaceship traveling at half the speed of light, and the moving observer shines a flashlight, then that moving observer will measure the light as running away from him at c, the speed of light. Now, common sense would then tell you that the stationary observer would observe the light moving at 1.5 times the speed of light.
Right. I mean, that's the way. I mean, that's the way you'd expect. If I'm the stationary, I see the spaceship moving at half the speed of light. I'm measuring it, and he's measuring light moving at the speed of light. Then I should measure this light moving at a speed of light and a half. The speed of light plus the half speed of this ship, right?
Light. But Einstein's assumption states that the stationary observer will also observe the speed of light to be going at the same speed as the moving observer, that is c. Now, the way Einstein explains length contraction is by saying that this strange way that light is measured by different observers to be going the same speeds then requires those different observers to also measure different lengths. That's Einstein's way of explaining it, with this assumption that the speed of light is always measured the same speed by different observers. So both Einstein and Lorentz's theories are consistent with experiments.
Einstein doesn't have a theory. Einstein just says it contracts. He doesn't say it contracts because of Lorentz's theory. And Lorentz has a theory that's based on Maxwell. So if you're just deriving something directly from Maxwell, well, it is a theory. Okay, semi-theory. I mean, and Maxwell didn't really give us a theory. Maxwell just gave us a set of equations based on experiments. So I mean, these are like, you could say these are theories or micro theories. Fine.
But Einstein's theory was.
But Einstein doesn't have a theory. Einstein just pulls axioms out of thin air, postulates, or whatever you call them, out of thin air, assumptions.
Accepted on the basis that it made fewer assumptions. Instead of positing that length.
What do you mean fewer assumptions? I don't know why everybody accepted Einstein. Why is everybody worshiping Einstein? Why did he become such a celebrity? What's going on?
Contraction and duration dilation are caused by a difference in motion through an ether that we can't even measure the speed of. All of the interesting effects of what is now known as special relativity could simply be deduced from these two postulates of Einstein's: that the laws of physics are the same for all non-accelerating observers, and that all of these observers measure the same speed of light. So the ether was never disproven. Physicists simply preferred Einstein's explanation, that these effects were the result.
Einstein didn't give an explanation. He gave an unscientific. It's not an explanation. He gave us unscientific assumptions. Let's pull two assumptions out of thin air. And everything that he predicted from that is true, okay? But that's not science. Science doesn't begin from, let's create two assumptions out of thin air. These assumptions have to be grounded. So Lorentz was grounded. Einstein is not grounded. Why didn't everyone just... So what's going on? So Lorentz already gave us the theory of relativity in a mechanical form, and Einstein gave it to us in a magical form. Why didn't Lorentz fight Einstein? Why did Lorentz accept Einstein? Lorentz should have said to Einstein, your theory repeats mine, as an assumption, instead of taking my theory and because you took Lorentz transformations, but Lorentz is based on Maxwell. So it's just Maxwell. You took Maxwell. Where's the theory of relativity? Where is the relativity in this thing? I think that the relativity comes only because of mass. I think for Einstein derived a thought experiment or created a thought experiment that proved that E equals mc squared. I think Einstein's relativity is Lorentz relativity, only he didn't give credit. I don't know why he didn't give credit, or did he? I don't know. We need to look into what happened over there. It's really confusing because Lorentz, it doesn't seem like Lorentz said there is no ether. Why did they abandon the ether? What is going on here?
Result of the speed of light being measured as the same for all observers. But let's remember, the ether is not just a hypothesis. Its existence is already proven by the existence of fields. Remember, fields are a property at a particular location, and these properties can't be properties of.
Yeah, when I heard this, this made so much sense. I can't believe that other people are hearing this and they're not saying what I'm saying. Who can deny this? I mean, if everything he's saying is true, I need to look into and review everything. But if everything he's saying is true, then what exactly happened? Why did everyone start worshiping Einstein? Or did it only happen with general relativity? And once they started worshiping him about general relativity, then they said, "Oh, he must be right about special relativity," and that's how everything got screwed up. Hmm. Yeah, we need to look into this.
Of nothing. Now, because they realize this on some level, modern physicists actually attribute these fields to something they call the quantum vacuum. But we got to remember the word vacuum means nothing, and it's not nothing. It's something. It has properties. Now, this isn't just a matter of semantics. So long as we say that these fields are.
Yeah, it's not just semantics. I mean, this is. Because when I talk to people, I argue them, and they tell me, "No, the ether has been debunked. This is the main resistance I'm getting from everyone. The ether has been debunked. That's why you cannot have gravity over the ether either. They cannot have a fabric. No." So, and I think this then comes to haunt them with quantum mechanics, because Maxwell is quantum mechanics. I mean, Maxwell is ignoring quantum effects. Maxwell didn't know or didn't take into consideration. There's no quantum effects at Maxwell's level. So we still need to go there. We still need, I mean, I think there is, of course, Maxwell with quantum. We need to look into that.
Are properties of the vacuum, properties of nothing, then we can't ask what that nothing is. Nothing isn't something we can ask about. Alternatively, if we decide to call it an ether, if we decide to name it as something, now we can ask, what properties of this something, of this ether, cause it to carry these fields? Now, in an attempt to answer this question, we can make hypotheses about how the ether might tie these different fields together, might tie all of physical phenomena together. Here are a few hypotheses that you might be able to make right off the bat. Creation and annihilation interactions of quantum particles show us that quantum fields are such that when they combine, they can create other quantum fields.
Okay. I'm just thinking as I'm playing him that at least we can say that the Michelson-Morley's experiment didn't take into consideration the option that the ether is flowing straight through them into the center of the Earth. So it's invariant relative to the center of the Earth. They never looked into that. Now, so at least in that regard, it's somebody should talk about that. I mean, someone should write a paper. Someone should do a PhD on this option that the ether does exist and is flowing through the experimental setup into the center of the Earth, because it is gravity at 6 million meters per second. And someone should run the experiment. But the Michelson-Morley's experiment should be run again. But according to this guy, according to Inductica, James, we should never. It should always be a null result. It should never create an interference pattern because of Lorentz transformation. What about I don't know, but it's certainly terrible that they didn't consider the option that it's always it's invariant towards the center of the Earth. that any way you rotate the table on a fluid, it's hovering on a fluid, it's suspended on a fluid. So it's always going to be pointing literally. Oh, it's always going to, right? If you're assuming that the flow of the ether is in accordance with gravity, then suspending the apparatus in a fluid by definition, basically by definition, because that is gravity, you're always going to be exactly ignoring the flow of the ether, the direction of gravity. So it's always going to be gravitationally invariant. So in that regard, it's a terrible experiment. It's a bad experiment. Has anyone conducted another experiment in which the table can be rotated in any direction? I mean, someone should check it. Maybe we would get an interference pattern. Oh my God. Okay, how much time we've been through? Okay, 45 minutes. Anyone? No, no one. No one is with us. Okay, let's continue. So we wanted to look into Lorentz invariant. So did I start searching? This is nothing. This is not it. Let me see. Lorentz. Okay, Lorentz transformation. So this is minute physics. Why can't I hear anything? No, nothing. Lorentz transformations, chapter 3.
The goal of relativity is to explain and
It's 12 minutes. But this is special relativity, chapter 3. Okay, it's supposed to be 1 minute physics, but then he started making long form. It's fine. Let's I don't know if we should listen to this. I don't know where he's going with this. Because I want to hear about Lorentz. Is he going to talk about what Lorentz did, or just Lorentz transformations, just assuming some transformation? You see where he's going? His video, he's talking about already space. I don't want that. Lorentz transformation should be about Maxwell's. He should start from Maxwell. I want to see, this is not a good discussion. I don't think this is, I need to see Lorentz I don't care. I need to see Lorentz contraction. Speed of light is constant. That's ridiculous. The speed of waves is a constant. There's nothing to do with light. There's nothing special about light. So the other question that I have is, what about mass? Because according to Einstein, you get the mass changes, relative mass changes. As you observe a moving mass, its mass increases. Its time gets dilated, its length gets dilated, and its mass gets dilated. Meaning its mass increases, its time increases, it slows down time, but its length contracts and its mass increases. So does Lorentz, but in Maxwell there is no mass, so Lorentz should not be able to predict mass. So maybe Einstein predicted mass. We need to look into that. Okay, I don't think he doesn't start from Lorentz. He doesn't. Does he? I don't think. He's just assuming. This is a big problem. Let's listen to what he says, because this is the problem with science, that they're all just assuming Einstein said this and Einstein said that. That's not science. I'm sorry, that's unscientific. You can't say Einstein said. I don't care what Einstein said or anyone said. That doesn't make any sense. You need to say, okay, we conducted this experiment, we got this result, it's been duplicated, replicated, everyone agrees that this is what they got, it's unbiased, it's double blinded, this way, that way. we have enough confirmations. I tried it myself. We have enough confirmation to feel confident, relatively confident with this result. Let's discuss this result or something like that. But that's not what they're doing. He doesn't. I don't think he's going to discuss anything. He's just going to assume Einstein. Einstein said this and that. Let's talk about. Let's start from that. All right. So let's listen. Maybe let's open it and listen to it separately. Share this tab. I think he starts with no sound. No sound. Okay.
The goal of relativity is to explain and understand how motion.
Relativity should not have a goal. You should start with an experiment. You should start with a phenomenon that we've noticed and we cannot explain. You should never start from the goal of relativity. That's ridiculous. Unless you're saying it's a theory to explain a phenomenon.
Looks from different perspectives, and in particular from different moving perspectives.
That's not a theory. You're not trying to explain a phenomenon. That's not science.
The goal of relativity is to explain and understand how motion looks from different perspectives.
That's ridiculous. That's not scientific. That is unscientific. I don't even know what you're saying.
And in particular from different moving perspectives. It's easy enough to describe motion itself. If something is moving relative to me, that means it has different positions at different times, which I can plot on a space-time diagram. This straight line corresponds to motion at a constant velocity of, say, v units to the right every second. And the question we're interested in is, what do things look like from the moving perspective? Of course, the answer to this question is a physical one and is determined by experimental evidence gathered by actually moving. And that evidence will come into play, but first we need to understand what it means in terms of space-time diagrams to view something from a moving perspective. We'll start with a key property.
That's a very good explanation. This is very reminiscent of in Galileo's time when they thought that the Earth is at the center and they were getting the planetary retrogrades and they had to have very intricate explanations to the planetary retrogrades. And then Galileo came in, and other thinkers, they came in with the heliocentric model that the sun is at the center of the motion of the planets, and then it simplified everything. And then when you switched your perspective to the Earth, assuming everything is rotating about the sun, then you could relatively easily explain the retrograde of the planets. Now everything made sense. It's much more, it makes sense. It's a good explanation. And this is very similar. So we're trying to, we're saying, this guy is moving. Now let's imagine what it looks like from his perspective. Really interesting.
Of space-time diagrams. When someone draws a space-time diagram from their own perspective, on that diagram, they are always, for all time, located at position x equals 0.
That's genius. So that's an inertial observer. That's genius. Very nice.
Since any object is always a distance of 0 away from where that object is. Or in other.
So, by the way, we're up to 171 subscribers. In the beginning, I was like at a constant 150, I think. Like I got from the time of the creation of the channel. In the beginning, I was at 150. I think I was adding a user, losing, adding, losing, until at one point I started gaining. So I think in the beginning we were cleansing the amount of subscribers, and now everyone seems to be in tune with what I'm aiming at on this channel. Okay, let's continue.
In other words, a space-time diagram like this represents.
Also, I believe that if you want to do real science, having a YouTube channel, a Discord. YouTube and a Discord, I think, are excellent for a YouTube channel. Are good for doing real science. And you should be anonymous, and you should be, independent. I think that's good research, and you should do all your research as much as you can transparently, so everyone can watch you doing the research. All your predictions, everything you're saying, everything should be public. So everybody, when you're embarrassed by a wrong prediction or analysis, it's fine. Everyone should see it. You're not God. You're a dummy dum-dum like everybody else. It's fine.
Presents your perspective
Hopefully, you're a little bit less of a dummy dum-dum than you were yesterday. That's all we can hope for. Like Greg, wait, I have a message. 1 second. You cannot see me. Let me respond 1 second on my phone so I don't make any mistakes. I don't want to make mistakes. Wait, why am I not getting? Okay. 1 second, please. Wait, how long? We've been 55 minutes. You know what? Let me stop here and we'll continue next because I'm getting a little bit anxious because of the coffee or something. I don't know. I'm getting a little bit jittery and I need to text back. So let's stop here and we'll continue doing our research after. Bye.